So a CMMS is a computerized maintenance management system, and its reason for existence, or why it's even there, is to maintain the physical assets of a manufacturing operation, as contrasted with everything that goes into building the actual product. And so those are very different worlds. For example, if you're a controls engineer, it's possible you almost never interact with a CMMS, because as a controls engineer, whether you're tuning loops or like calibrating instruments or specing out SCADA systems, whatever you're doing, you're almost solely focused on producing a product that either goes out as a continuous stream like a chemical or a power plant, or it goes out in discrete chunks for a discrete manufacturer. But like, you're making a product, that's what you live for. Contrast that with a maintenance engineer whose job, and a reliability engineer whose job is to keep the infrastructure of assets that make that product in good shape. And they're totally different worlds. There are cases in which there's like metaphorical comparisons between the two, but it's best to keep them separate in your mind. The maintenance and reliability team is always about maintaining the physical assets of production. And then somebody like a controls engineer, or oftentimes a manufacturing engineer even, cares about the product, what's inside of the pipe or what's coming out into the back end of the warehouse. And you think very differently depending on which world you happen to be in. And so MES, that's production world, that's the product world. CMMS, that's repairing the physical assets. And where they overlap is the production team needs the asset to be up and running. The MES schedules batch and production runs. The CMMS schedules repairs. And so, yes, we very much would like to know the schedules for both of those, because they have to agree with one another. You can't repair a machine while it's operating. And likewise, I don't know what the inverse of that would be. When a machine is down, you can't produce. The fourth, what I would call the fourth critical module, is the scheduling module. So some people talk about the planning module as being separate from scheduling. That's fine if it might actually be separated out that way, like in the icon that you click on the left-hand side of your software. But for all intents and purposes, the planning module is about filling out the work orders. We describe that as a subset of the work order module. It's nomenclature, doesn't really matter. You're doing the same thing either way. Scheduling is different. So scheduling is you're looking at a calendar and you're figuring out the puzzle. You've got a finite number of technicians that they sometimes can go on overtime, they sometimes can't, but they're a finite resource and you can't invent them out of thin air to work in parallel to one another. And so you have to figure out, given my constraints on available parts, on when production is willing to release a machine to me, and on what tools I have and what technicians I have available and whatever overtime constraints I have, how do I fit the puzzle on getting the most work done that I can and in the most efficient way possible? And that is why the scheduling module exists. Not an easy discipline. The discipline is virtually identical, at one level of abstraction, it's virtually identical to the MES. In the MES, instead of thinking about repair parts, you're just thinking about direct parts that are going directly into the recipe of the thing. But beyond that, it's literally the same puzzle that you're trying to solve. You're just trying to schedule when you have operators instead of technicians. And so that's, in that respect, it's like a perfect segue into MES, in that it's the same assets, the same different technicians, but they're working on the same assets. And how do you schedule in an MES? And so maybe we should foray into MES world from there. So MES, why does a manufacturing execution system exist? The simple reason is that scheduling the combination of what you're going to produce on a factory floor and the operators and spare parts that you need in order to produce them is a really complicated problem. It's not the type of problem that an individual person could solve by staring at Excel or thinking really hard. Like, it's well beyond the capacity of an individual human brain to effectively solve that problem. And so from a technical perspective, there is this whole discipline called linear programming that's dedicated to solving a giant messy problem under resource constraints like that. That's not the point of this talk right now, but the point of this talk is that humans can't do it. And yet, what you'll see in the vast majority of production plants out there is a human and an Excel spreadsheet, like pulling his or her hair out, trying to figure out what is the optimal solution to this problem right now. What I would say is that for relatively steady operations where you only got a few SKUs, you're kind of making the same thing every day, there's a base load that you know that you need to put in, there's a fighting chance that you can get by without it. And yes, a human, like that problem is tractable because there isn't that much variation. But the moment that you get into expanding the number of SKUs that you have, different operators and or assemblers that are non-fungible. Non-fungible meaning you can't just take them from cell A and put them in cell B ad hoc, like they're only trained in one particular area. The moment you add that, and the most critical third layer of complication, which is schedules changing at the drop of a hat because a part didn't arrive, a customer complained and said, you're going to fill my order this week, or I'm calling your CEO. Like, that's just the stuff that happens in the day to day life of a manufacturing organization. And so, a human being, there's just no chance you're going to be able to optimally respond to all of these unknown things in this giant puzzle. Hence the need for a manufacturing execution system. And then Dylan, you can probably go into some stuff that I didn't explicitly cover there, but it's also important to have traceability. Like, okay, we have a batch record, which specific chemicals are going into this particular reactor for how long. Somewhere that has to be organized. And an ERP can do some of it, but poorly. And you'll very often find yourself wishing for quality purposes that you had an MES to organize all the relevant data. And so that's kind of my background on MES. It's a logical extension of the supply chain and ERP module is how I think about it. And it does the stuff that ERPs and supply chain software does poorly, the MES does well. And that's how kind of I think about it.